Okay, so we've reached the end, and I want to just give a little bit of last minute advice going into the AP exam and get maybe a little rah-rah on you at the same time. So let's see if we can get this thing started. Maybe we can. Let's see, here we go. All right, so this is just last minute advice for those of you taking the AP exam. Now, keep in mind that your exam is long, all right? There are two 90-minute parts. One is multiple choice, one is free response. So the multiple choice is just like the practice multiple choice we did with 40 questions. You're expected to get it done in 90 minutes. We did run a little bit long. I know that when you guys are doing this at home, that it does take a little bit of extra time, but you're going to have to do some good time management here, and anything that you run into that just kind of messes with your mind, it's just something that you need to leave and come back to, so that that way you can gain confidence, because actually there are a lot of easy multiple choice questions. They're not all hard, all right? But when you get to a hard one, you're going to want to do some time management. Now, section 2 has 6 free response questions. 5 of them, I'm not going to say they're all super easy or anything, but there may be 2 of them that will challenge you, I'm thinking, in general. The other 3 should be pretty straightforward stuff. Those run about 13 minutes. So again, if you've brought a watch, or we'll talk about watches later specifically, but if you have a timing device with you, then it should be about 13 minutes for each of those shorter questions, and then you're going to reserve another 25 minutes for the last one. The last one's longer, usually the weirder one, and it counts the most. Got a little advice on how to handle that one coming up. Now you're going to get questions on anything, experimental design, seen that, exploring data. Now it says graphing, but you won't be doing any graphing, you'll just be interpreting graphs. Probability shows up, inference. So definitely look over your inference before the test. Make sure you get your assumptions right. And then you can get a wildcard question that's kind of like something we did and kind of different. I'll talk a little bit about that later. All right, calculators, definitely bring your own. The school will provide a limited number of them, but not enough for everybody. They're just there for an emergency basis, and you're expected to bring your own, either the ones you personally own or the ones that were checked out to you. All right, and while we're at it, if those things take a rechargeable battery, charge them up the night before. Don't just think that they're going to be fine. Just plug them in, wake up, they'll be ready to go, and there won't be an issue. There's nothing like bringing a calculator in and having it be redlining, and you don't know it until it's dead. So please bring your own. Formula charts and tables are given, like T-star tables. For those of you with TI-84s, turn on your diagnostics. If you have the app catalog help, that needs to be turned on. I don't think you really need it at this point, but definitely make sure your diagnostics are on, because that will allow you to see R and R squared when you do a linear regression, okay? If you don't turn it on, you won't see those things. Okay, so yeah, the people that read your answers and score this are going to be very interested that you can have the right answer. But they're also interested in your ability to communicate, not just in a manner that people can understand, but you will definitely communicate the methods. In other words, put down your work, right? So if the only thing you write down is an answer, especially if it's a numeric one, and you don't show where that thing came from, don't plan to get credit for it, even if it's right. So convince that reader you get it. You get the question, you understand what it's asking, you're able to answer it, and you do it correctly. Right? So there it is. Okay, so multi-part questions in your FRQ, those typically do have several parts, right? Just take a moment, read the whole question, see how the parts interact, how they're related, if they are or if they aren't. Like on the probability 4-part thing where we started out with normal calculations, then went to binomial, then went to geometric, then went to sampling distributions. All of those are related. So you can just kind of work a strategy out in your mind, while you're reading it, instead of just reading the scenario, doing one part at a time and being surprised. All right, so if one part of the free response is asking you to use something that you got from a previous part, definitely make sure that you grab it and use it. And if for some reason you weren't able to do part A, but you need whatever that answer was for B and C and D, then by all means make up something. Admit that you did it and just pick something that you think is reasonable to the setting and just say, I can't answer part A, but I'm going to use this number to move forward, right? You don't want to leave anything blank. That's just leaving points on the table. And you can get a lot of points, and you're not expected to get all of them. It'd be nice if you did a perfect job, but I have yet to meet anybody who has, to my knowledge. All right, so definitely answer what's being asked, and spend more time reading, less time writing to make sure you really understand what's being asked. I'm kind of drilling that into you, I know. When you have gotten to the end of your question or your answer, you've answered it, it's pretty clearly done, then just stop. Don't go on. All right, I'm the worst at writing too much. And then when I get to the end of my test, I end up with just enough time to finish instead of maybe a little extra in case I encounter something weird. So don't write a novel for each one. Definitely write out what you need to write, answer the question, be done with it, move on, because there's more to do. So don't worry about filling in all the space they give you. They always give you more than you need. So especially if you have something numeric, then if you have to draw a normal curve and then say random variable x is approximately normal with mu and sigma, and you write out getting things to at least the form for making things into a z-score, all of that along with your answer may only take a quarter of the space they give you. And if you know it's right, then don't sit there and think, wow, they gave me so much more space, I got to keep going. Nope. Just got to move on. Okay, context, context, context. If the question is about bugs, then the answer needs to be about bugs. All right? If there's some kind of flow to the question, that same flow should appear somewhere in your answer. This is really important, like if you're defining what mu is in inference, or if you're defining what beta is in inference, or p, or anything, right? Because once you've defined what those things are, then you're going to have it already built in so that you can put it into your conclusions, right? So make sure you're defining p and not p hat, mu and not x bar, and define them correctly. And if you have some kind of distribution, then tell them what it is. Okay, this question is referring to a normal model with parameters mu and sigma, or it's binomial with n and p. They love the shorthand. That saves you writing. If it's geometric, tell them this is a geometric random variable. And then when you write out geometric PDF or CDF, then you'll be justified in doing it. All right, vocabulary has a lot of nuance in it, right? So terms like normal, you got to be careful what you call normal, and we'll talk about that in a minute. Independent, that does not mean mutually exclusive, which some of you think it does. If you're saying normality of the distribution, well, there's any number of distributions out there. Which one is approximately normal? Well, perhaps it's a sampling distribution, and that might actually summarize in one little part of a sentence why I had you write so normality of the sampling distribution is approximated, because they want to know which distribution. When it comes to normal, most everything that we're going to declare as having met a normality check is going to be approximately normal. Think about it. There's central limit theorem. There's graphical ways of verifying normality. We can assume it, right? But it's not going to be exactly normal unless they say, this sampling distribution comes from a population that is normal, or something like that. If they say the population is normal, boom, all the sampling distributions, no matter what size your sample is, will also be normal, okay? So that's one you can skip saying approximately normal, but all the other ones will probably be approximately normal. Don't mix up p and p hat, don't mix up mu and x bar, those kind of things. HO and HA have parameters. You define parameters. You only use p hat and x bar as sample evidence to support claims about parameters or estimates about parameters. That last question is kind of a bear. Question number 6. It's a 25-minute question is their recommendation. My thinking is that you can, kind of work through the first ones, the shorter ones, and, you can, oh, here comes a yawn. I tried to stop it. But if you can, minimize the time you need for the prior questions, and that just builds more and more and more time at the end. So you may have 30 or 40 or even 45 minutes for the last one, and since it's weighted the most heavily, then that's the most time you want to invest into it. So what I would suggest you do is once you get to the free response section, read that question number 6 in its entirety. Just take a minute, read it. If you feel good about it, then go for it. Answer it first. And that way you can move through the rest of the section with a lot of confidence. It'll give you momentum and confidence. Well, what if you don't think it's okay? Then leave it till the end. Go back to the shorter ones. Build up momentum, build up your confidence with them. Then you should have extra confidence, momentum, and extra time when you get to the harder one. And I'll give you an example of what a harder one might seem like in a little bit. And again, watches are great. If you can keep track of time, then you will be the master of time. And you'll know, like if you get past 13 minutes for a short question, maybe it's time to just leave it and finish it after some of the other ones. So yeah, a watch is a good thing unless it's a smartwatch. That's a bad thing. Or if it's a watch that makes a sound, that's a bad thing too. All we want are happy little watches that you can barely hear ticking when you hold it up to your ear, okay? So please don't bring anything else. You'll get in trouble, school will get in trouble, we'll all get in trouble, and that's not good. Okay, so exam writers are not out to trick you. Sometimes I wonder. They do write great questions. But my definition of a great question is when you see a question, you go, ooh, that's going to make me think, and you can sit down in a quiet room with no time ticking down, and you can work it through and see if you're right, see if you're wrong. If you're wrong, you can fix it, you can learn from it, all this kind of thing. But when you've got a challenging question and the time is ticking down, maybe that's not such a good thing. All right, so when it comes to not trick you, and maybe as an example of a question 6, about 2003, I was still at school at 4, and I was just finishing up some things and thinking maybe some of the kids will run by. And they did, but they ran by with like torches and pitchforks, and they were not happy. And so they came in and they said, you know, this test, I don't know, you know, the last question was something you didn't teach us. And I thought, I didn't teach you? What are you talking about? I taught everything in the curriculum. And they said, well, you didn't teach everything because they had a one-sided confidence interval, and you didn't teach us about those. And I'm thinking, oh no, a one-sided confidence interval. What was I thinking? How did I not even know that it was a thing? So they stayed a little longer, and they kind of grumpily left. And I went home feeling pretty despondent and questioning my abilities as a teacher. And at the time, we had kind of a conversation board that we could get on the internet. And I was on it, and every stats teacher in the country was like flipping out because of the one-sided confidence interval. Well, fine. While I was on the board, in came a college professor, and he said, yeah, you know that question about the one-sided confidence interval? I wouldn't beat myself up about it too much because there's no such thing. Right? No such thing. So it wasn't me. What they did was they wrote out a question with a one-sided confidence interval, and it related to a regular confidence interval, such that if you understand the construction of it, what it's supposed to do, you know, for two-sided, then you can shrink it down to one-sided and answer the question. And sure enough, you know, 2 days later, when they released the FRQs, I got the question, and it wasn't that hard. Then now, think about it. If we're blowing up like those kids did back then over a question like that, then the whole country is blowing up, right? So anything that you find difficult, the whole country is going to find difficult. And while College Board says they don't grade on a curve, every time they've hit us hard with questions, our basic score distributions haven't been that much different than any other year. So don't freak out about stuff like that. Just do your best. So keep in mind that this is really, to get a 5, you just need about 70% or 70% of the points to make a 5. You need about 45% of the points to make a 3. And that's not bad. But you know, think about it. In college, if you have had a prior course somewhere else or some kind of learning experience that would apply to a course that's on your recommended course list, you can take, in many cases, a CLEP test, and you can test out of it and get your credit, not spend the money and all this other stuff, not buy the book. Well, turns out to get college course on a CLEP test, you need about 50%. Because, you know, you probably think that doesn't seem like you really know a subject. But if you think about everything you've learned in high school, if I were to ask you, recall that immediately and teach me on the spot things you haven't done, like maybe Algebra 2, you haven't done it for 2 years, you know, you might remember half of it, which is kind of the way all coursework is supposed to be. And if you need more, you can go back to a resource like a textbook or some notes or whatever, and it'll all come back to you. So a working knowledge of anything you've learned is about 50-50. And it's a little higher standard on an AP exam, but trust me, no one makes 100 on this test. I have never, ever made 100 on one of those tests when I've taken them on my own. And so you got to be comfortable with that. In fact, I've the test that I gave you that was multiple choice as a practice, that thing, I missed 2 of them in the multiple choice. And they were the same 2 I had missed 2 years ago on the same thing. And I was like, duh. And I did the same foolish, you know, thinking. I think on one, the other one I just kind of just messed up. But I remember one year, they released a practice exam. I think it was 2011, and I missed 7 questions out of 40. It was the hardest thing ever. I've never seen it that hard before or since in any capacity. But so just be comfortable. You're not going to make 100. Just get as close as you can. Okay, so just a few things to remind you of. if they have questions on collecting data, just remember there's certain things that separate, experiments from just sampling, like for surveys. For example, you can stratify to make your sampling more accurate and to reduce variability. Stratified random sample, the equivalent in an experiment is blocking, but you don't mix those terms between the two. There are, processes for sampling for surveys and processes for experiments. Just read up on them and make sure you don't confuse them. Oh, and the biggest one is that for experiments you impose a treatment, and for any other study you don't. Blocking versus stratifying, I think I just talked about that. So, all right, don't mix up multi-stage and cluster sampling. Remember, multi-stage is like simple random sampling in ever decreasing like geographic areas, or ever decreasing groupings or whatever. Whereas in a cluster sample, you just get a whole bunch of, let's just say geographic areas, although it can be done in non-geographic settings. And you just pick a random sample out of each one, like the counties in Texas, pick maybe 5 at random, and then go survey all the people in the 5 counties. All right. So there's not a kind of decreasing level of sampling like there is in multi-stage when it comes to cluster sampling, but kids still mix it up. In fact, when it comes to this, you probably ought to review simple random sampling. Remember, that gives every group of n individuals the same chance to be picked. Stratifying, systematic was another one. Multi-stage, cluster sample, all of those probabilistic sample methods have their own little nuance to them, so look those over. Describing data, when you're asked what is the IQR of this setting, it is Q3 minus Q1, but it's actually what that difference is. So don't just say, oh, it's Q3 minus Q1, and then just leave it like that. Actually get the number for Q3, subtract whatever Q1 is, and then report the difference. Okay, I meant to change this. You will not have to construct graphs by hand. Maybe if you're doing a match pairs, you can stick the numbers in your calculator, get the difference, and then box plot the difference values to see if you have an outlier, but you're not going to have to draw it. All right, so just know how they're put together. Like box plots are built off of the 5-number summary, like quartiles. Stem plots, definitely review this. I've had kids mess this up. Like in the last question of the inference packet, I saw some interesting ways of reading the data back off of a back-to-back stem plot. It didn't look good. Same thing for histograms. Just know how they're constructed. Anything that needs a label, give it a label. All right, refer to graphs explicitly. If you have a dot plot with a gap, say it looks skewed left, it has a gap between this number and that number, say what those numbers are. If you're going to refer to the median, you can probably count where the median is. It's just the middle number or the middle spot. So definitely refer to things very explicitly from graphs. Look at all aspects of your data: center, unusual characteristics, shape, and spread. Remember, that's CUS, or we may have learned it with SOX, either way. And don't leave any of those out, because if you do, you're going to lose points. Don't get something skewed left and tell me it's skewed right, or vice versa. Whichever way the thing drops off, whichever side, that's the direction of the skew. All right, if you find yourself getting overwhelmed or worked up or anxious or panicky, just stop what you're doing, shut your eyes, take a mini mental vacation, breathe deep, slow breaths, and maybe leave what got you worked up and then come back to it. All right, when it comes to inference, it looks like everything that, at least everything we did second semester was inference pretty much, but the whole course has way more stuff than just that. So don't worry about everything being inference. It won't be, okay? Hypotheses are about populations. Again, no p-hats, no x-bars when you write HO and HA. Check assumptions and conditions. That means you need to go back and see what the conditions are for chi-square, what they are for linear regression t procedures, what they are for proportions, what they are for means. Don't mix them up. Some they have a bunch of things in common, others don't. Remember that confidence intervals also have assumptions. That was one thing in the inference portfolio. Kids were not writing assumptions for confidence intervals. Hey, if a confidence interval is just the other side of the same coin as a test of significance, then you definitely need to check assumptions. All right, if you're going to say p is less than alpha, let the reader know what p and alpha are. All right, definitely make sure your hypotheses and conclusions match. This did not happen on all the problems that some of you wrote up on your inference portfolio, and as a result you got big gigantic p-values, which is not out of the question to get in some cases. But if they do happen, you should check the direction that your alternative is, because it's probably backwards. All right. If they want you to interpret a confidence interval, it is the script. We are 95% confident that the true proportion of people who sleep in on a Saturday fall in the interval, blah, blah, blah. Or interpreting a confidence level. That's where you say what the 95% means in the statement. So it means that you're really 90% comfortable with the process that built the interval that you're using to estimate. You're expecting, if you do this process indefinitely, that it'll be 95% successful, or whatever the percent happens to be, in trapping the true parameter. And then, whatever the complement is going to be that percent of not trapping it. All right, when you're doing regression, look over the graphs. I don't think you'll have to build one either on paper or in your calculator, but look it over and see where the outliers are, see if it's straight or curved, all that kind of thing. If it's linear, an R value alone won't tell you or establish the linearity. It's only going to tell you the strength and the direction of the relationship. You have to eyeball the scatter plot to see if you're comfortable calling it linear. Be able to read computer output for regression, for chi-square. We spent a day on it. We had t-tests. For means, there would be all manner of computer output that they could draw from. So, yeah, be able to read it. That's why, again, we spent a day on it. When you interpret R, this is a good way to see context. So, for example, let's say you get an R of 0.5. Well, that would be a weak positive linear relationship between whatever number of math classes a person has taken and yearly income, or whatever the context happens to be. All right, now for the mushy stuff. Look, it was a wicked year. Learning from home is, I got to give it up to you guys. That's something I don't know that I could have handled day in and day out for a 7-period school day. It's lonely, it's boring, it's hard on your eyes, it's hard on your nerves, it's easy to be distracted, it's just terrible. And I'm sorry you had to face it. And you know what? We did the best we could. I wanted to do way better. Not the least of which to give you a better experience, but if for no other reason than to get to know you guys. It got to where at the end of the year, many of you just kind of hung out behind the little black rectangles, and if you were to walk past me down the street, I probably wouldn't recognize you, and that's not the way it was supposed to be. But under all of the things that we could find that we didn't like, we did the best we could. Most of you, I think, learned what you could and what you needed to learn, and so you know what, I'm just going to have to accept the way things went and not feel too bad about it. All right. So go show them what you know. It's sort of like they're challenging you. So rise up to the challenge. Show them what you know. Show them you know it well. Show them that all that time you invested and all that energy that you spent just through the endurance was something that gave you mastery, and now you can show them that mastery. So thank you. Thank you for all the homework you didn't want to do. Thank you for signing in, and I know a lot of you fell asleep, not a lot, but a few of you fell asleep because you were still there when everybody else left, unresponsive. But thank you for enduring. So get ready for all of your exams, or earn your college credits, save money, enter as a sophomore or however high you can get, because you can earn your way up without ever setting foot on a college campus. So do a great job. I will be available to help you up through the 17th, and all the best to you moving forward. So on that note, it's going to be adios and good luck.